we're thinking about the monopoly equilibrium. We understood that marginal revenue was always less than price because the monopolist, in order to sell an extra unit, has to lower price because the monopolist is, the demand curve is really the constraint on the monopolist. In the competitive case, the firm could sell an extra unit, an extra unit, an extra unit, and they had no impact on price because they were so small relative to the market. Not true for the monopolist. Only game in town. Want to sell more? Got to lower your price. So let's think about this, and we'll start by saying, let's assume that we have a linear demand. If we have a linear demand curve, we'll put it down, it looks something like that. Now, a linear demand curve would be something in the form of P is equal to A minus BQ, where A is the vertical intercept and B is the slope. It's actually minus B, but the slope is minus B. I know that marginal revenue is the derivative of total revenue with respect to output. Well, what is total revenue? Well, that's pretty easy. Total revenue is price times quantity, okay, which in this case would be A minus BQ times Q. Where'd I get that? Well, we know from here that price is just equal to A minus BQ, so I'm going to substitute this A minus BQ in for price. That's this, times Q, which I can, in fact, run the Q through it, and it's AQ minus BQ squared. That's total revenue. Now, marginal revenue is just the derivative of that with respect to quantity. Marginal revenue would be the derivative of total revenue with respect to quantity, which would be the derivative of AQ minus BQ squared with respect to quantity, which is equal to, and for those of you who have an aversion to calculus, not pulling any rabbits out of my hats, this is true, A minus 2BQ. Now the cool part about this is it shows that for a linear demand curve, I just drew a general linear form here, right? For a linear demand curve, the marginal revenue curve for that is itself linear. This is another linear form. Has the same vertical intercept, A, and it goes down at twice the slope of the demand curve. So the marginal revenue curve would be itself linear and go down with a slope equal to minus 2b. You don't have to do calculus. That just proves it for you. From now on, just remember that for a linear demand curve, and we've said all along we're basically going to stick with linearity because it's much more tractable. For a linear demand curve, the marginal revenue curve the monopolist face is also linear. Same vertical intercept, twice the slope. Well, that means that for equilibrium, when we're talking about a monopolistic, a profit-maximizing firm, you've got a marginal cost curve, you have a demand curve, and you know that since it's a linear demand curve, the marginal revenue curve has the same vertical intercept and twice the slope. So the monopolist will produce where marginal revenue equals marginal cost. We'll call this Q star sub M for the monopolist. And that monopolist will charge the price that that market bears for that, P star sub M. So the monopolist in this case will charge a price where the marginal revenue equals marginal cost. That's the output he wants to produce, but then he or she will charge the price the market can bear there. One thing you should note, at this equilibrium, you can see that the last consumer paid a lot more than what the cost was to produce. And it looks like if the last consumer, if you could just get one more consumer out there, that consumer would have value in excess of what it really cost you to produce. The problem is that if you try to elicit an extra consumer, you've got to lower the price to all these inframarginal ones. And while you can get a little more out of this consumer's pocket, when you net off all the people you're foregoing, the true marginal revenue for that extra consumer is less than what the marginal cost of production was. That's why you stop right here at Q star sub M.